Hello and welcome to this course on Relational Database Management System. I am Venkatesh Vinayakara. My introduction to databases happened in the late 90s when I was a student of computer science and engineering. Later, I was fortunate enough to be working in the software industry, where in the first 2 years I was heavily developing applications, database based applications. Um, and then the uh, curiosity in databases just increased. Uh, okay, so rest of the stuff about me, I believe you already know. So let's skip it and move on. So, any idea who this personality is? Yes, Larry Ellison of Oracle Corporation. There have been several stories of rags to riches, and here is probably one more. Uh, from a normal student like you to becoming a world's richest man, what transpired in the life of Larry Ellison? So um, somewhere in his middle career, there was in his early career, I should say, um, DBMS came his way and it changed his life. So, what magic did DBMS actually do? So, this course is not only about the theoretical foundations of DBMS, but also a story of a rags to riches as well. Okay, so let me introduce you to the textbook definition of a database management system. A DBMS is a collection of two things, interrelated data and a set of programs to access those data. The collection of data is usually referred to as a database. All right, so this seems to be straightforward, but naturally we get one question here, which is why files are insufficient to store data. Please pause your video here and try to note down some points on what comes to your mind why files are insufficient to store data. When I ask this question to my students, I get plenty of answers. For example, redundancy. If you store information in files, it's possible that multiple files carry the same information. There could be inconsistency due to redundancy again. So when, let's say, on one file we store that apples are red in color, in another file, let's say I store that this apple has turned brown. And if there is a question on the color of apple, we just don't know. There could be inconsistent data lying across our files. Difficulty in accessing data. Well, you ask any programmer, he'll tell you that accessing files is one of the bad things that a programmer would like to do. The input and output costs are too expensive, so we don't want to deal with files. Nowadays, we have too many file formats. That's another problem to deal with: PDFs, PPTs, JPGs, GIFs, text, and so on. And along with files come other requirements as about backups and security. And these days, we have gone past the uh, the era of one person being able to do something. The softwares have become massive. So collaboration is key and we need features to collaborate. Again, this doesn't come in built with file handling. We need to develop them separately. Integrity of the files. How do you know your file is not corrupt? Checking files every time when you use a file. So these are all things that can be done, but then have to be done by every single programmer whenever he wants to store data in files and want to retrieve them by himself, which is a pain, and that's what we are trying to deal with here. For these reasons, we would rather like to have a database which helps us by taking care of these issues rather than using files and addressing them ourselves. Let's look at a brief history of um, what happened with data storage and retrieval before we jump into the journey of databases. Way back in 1950s, we were used to tapes and punch cards. Predominantly, these were sequential data access devices. And about 1960, we could do direct access with hard disk, and this is the period when Cord was working on the relational data model. UC Berkeley built the first relational DBMS named Ingress. In 1980, SQL became a standard. For who for those who don't know what SQL is, it's a query language which allows you to query databases for data. For example, let's say there is a database with train timings, and I want to know what is the time for a specific train. I could issue a query using SQL language, a language that the tool understands, and I would get back the train details. Uh, and in just about 1980s, the database sizes were increasing and people started looking at parallel and object-oriented and distributed databases and DBMS systems. In 1990, multi-terabyte data warehouses were trending, and this was about the time when web commerce was picking up. Well, um, if uh, if around this time you you had believed in web commerce, then probably towards the late 90s, you would have started accumulating Amazon shares, and by now you must be a very rich person. Uh, and then in about 2000, XML standards emerged, and now we are in the era of big data and NoSQL DB. Uh, the core structure at CMI is pretty much mimicking this history. So we start with a mini course on DBMS, which is this course, and then we get into a 4 credit full course on big data and NoSQL. And then we would follow that up with an application built over big data, as in search engines in information retrieval. If you still stick with me, you would probably sign up for an advanced course in information retrieval for 2 more credits, where we discuss the technical nuances and research trends on how to put this big data to work. Okay, so let's jump into the objectives of this course. There are two major objectives that we want to deal with. Firstly, assume you are in the 1960s and assume we only have files. We do not have any DBMS like, let's say, SQL Server, MySQL, Oracle, etc. The first question is how to build a DBMS. Now, this is the part I love. Um, Whenever a new system has to be built, there are a variety of questions. Fundamentally, how do you model the underlying data structures? How to really build a system? How are systems built in general? Not specifically to DBMS, but this applies to any system. So how does that happen? I'll try to share some of my knowledge here. And of course, assuming you are now in 2020 when the DBMS systems are pretty mature and available, how to use a DBMS. So we'll focus on MySQL and SQL specifically while addressing this objective. So these are two objectives that we want to deal with in this course. We'll pretty much follow the database system concepts book, 6th edition by Abraham Silberschutz, Henry Korth, and Sudarshan. There is also a 7th edition, but a large part of this 7th edition covers big data, blockchain, distributed computing, which are topics of our interest for the big data course. So I prefer to stick with the 6th edition of this book. Here is a link for the book. You, of course, have course material and slides available here, which I have borrowed contents from. So if you are interested in the author's original slides, you should find them here. For This course, uh, if you follow these video lectures and refer to these slides, you should pretty much do well. This book, let me warn you, is a pretty thick book, a large one, a big one, and but however, I do recommend reading this wonderful book if you have time. All right, so that's about it for this introduction. In the next class, we'll start with uh, the foundational concepts of a DBMS. Thank you.